Hey everybody, this is Larry. This is me going to three of the weekly contest 368. Minimum number of groups to create a Reddit assignment. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this problem. This one is kind of one of those proof-based, I would like to call shady problems. It kind of uh, incentivizes people who are YOLO because basically the people who do well on this problem are people who are YOLO and just don't prove, or people who are very good, which is fine because I mean that's what it's measuring. So then now at least I consider it where like I'm in the middle range where I'm like, I'm good but not too good. So then I have struggled proving this one, and that took a long time. I also had a silly mistake or two, but so that part is on me, just to be clear. But I took a long time, and I kind of went back and forth on it. So it's not just like I spent an hour on this. I But I will admit that initially I did spend a good amount of time on binary search, and when binary search didn't work, I didn't know what to do per se. But I did have the structure to kind of change it to what I end up having. So binary search, the idea behind binary search is that given a number, let's say x, we can try for each group x and x plus 1, right? However, it turns out that if you have, say, a number like a 10, then 5 is possible, but not 6, right? But 10 is possible, obviously. So because of that, and that's the minimum number of elements in a group. So it's either 5 and 6. So when I say 5, I mean groups of 5 and 6. And when I say 6, is groups of 6 and 7, right? So that's the way that I kind of thought about it. And to be honest, that's pretty much it. That's how I spent a long time figuring it out. And then at the end, I just kind of, during the contest, I YOLO'd a little bit on the proof. I think there is something about like, and I just kind of didn't really think about it this way during the contest until like I kind of YOLO'd a little bit, to be frank. But I think the way that you would think about it is kind of constructing the worst case. What is the worst case for this problem, right? The worst case for this problem is actually, well, I mean, n to 10 to the fifth, yes, but the composition matters for this problem. So what is the worst case for this problem? The worst case for this problem is not that all numbers are the same or all numbers are different, right? Because if all numbers are the same, then you only have one number to try, and if all the numbers are different, you also have only one number to try because you can only have one of each element, right? So you only have one group, or sorry, group size of one, right? So turns out that the toughest case is going to be if they distribute it like in a square kind of way. You can kind of think about the way that I visualize these is that, yeah. Well, let me go over the algorithm real quick first, just to kind of be clear. So some of this is structured like I did binary search, and it is because I did binary search. So forgive me there. And I even have this code I just didn't delete. Okay, fine. But yeah, first I do a frequency table. Just count the number of elements in each and how much times they appear. The actual numbers don't matter. It's just about how many times they appear, right? And then after that, I just brute force from 1 to min, meaning group size of 1 or 2. So when I say when I is 1 is a group size of 1 or 2, if I is 5, it's going to be group size of 5 and 6. So we kind of do it that way. And then if this is possible, then we do the math and calculate, and that's pretty much brute force, right? So good. What is good? Basically, the idea here is that, okay, given a certain target, can we, let me write this. Can we have group size of target and target plus 1, right? And how do we figure that? Well, first of all, G is just the number of groups, but obviously we divide the number of targets to the number of groups, and then L is the leftovers, right? And basically, there are two ways you can think about the leftovers. And it's the way that I did it. As first of all, it's possible if the number of leftovers is less than G, because for example you have like 5 5 5 5 5, and then the leftovers is going to be say 4. Then you just kind of distribute the 4 into 6 6 6, 6, right? 4 of these. And the only way that this is not possible is if target is too small. So let's say you have 4 and then let's say you have whatever. Let's just say 100 and then you have 4 left over. Sorry, but target is too big. Then in this case, you can only distribute this to 101, so 100 will not work for that reason, right? Because you distribute it and you have 3 left, and that's all you can, right? Yeah. And then basically, if it is possible, then we just calculate it. And here it's a little bit tricky. To be honest, this is basically calculate the number of groups given target, right? So here I have two ideas. One is this is exactly target, right? And this is the idea that we talked about. So, and we know that in all these cases L is less than or equal to G, because if it's not, then we would have already this would already return false, and it's not possible. So that means that there's G groups that we care about here. And here this is given exactly target plus 1 groups. Yeah. Basically, yeah. Because keeping in mind that we can do target and target plus 1, but sometimes having only target plus 1 groups makes sense, right? For example, if your target is if your target is 5 and these are your numbers, then you have either 6 or 7 of these. You have 7 of these 5s or this, and that will still be good, right? Because now you have 6s instead. So that's basically the idea here, is that now we try for to see the number of the bigger groups, and then we see the leftover. So if the leftover is either 0 or if it is target, because if there's no leftovers, then obviously this fits the target plus 1, or if it's exactly target, then that's also good, right? Otherwise, and in an opposite case, we set it to infinity otherwise. I guess this is unnecessary actually. But yeah, if it's not equal to target, then it should be fine. If it's 0, did I have it like this? This is way awkward. Oh yeah, this is impossible but it will also never be target, right? But yeah, otherwise, if we do have leftovers, so that means that that's not the right perfectly. I don't know. This should be an or. Maybe no. I mean, this is not L2 will never be target if it's greater than G2. So, I don't know. This somehow ACs, but it's a little bit confusing. But yeah, if we have L2 left over, then we create an extra group. Yeah. If this gets challenged, I apologize. But yeah, otherwise we just take the group of this or this, whichever is smaller. But this is only G2 is only smaller, bigger if this is infinity, of course. So yeah, so then this is brute force all the way. And then now the question is, what is the complexity here, right? The way that I think about it is that I know that I'm on away, but I'm going to try to draw this real quick. Hang on. And the idea here is that, okay, so let's say you have one appearance of 10 to the 5th elements, right? So that's going to look like this. Or you have 10 to the 5th element of one thing, so it's going to look like this, right? So that's basically almost like, so that's the work you do, right? But it turns out that the worst case is probably just going to be if they're like in the middle, if they're like square root of n and square root of each square root of n in appearance, and then here in that case, if you do the square root of, if the biggest appearance is square root of n, then this is square root of n, and the calcs of I will only have square root of n distinct values. So this is going to be square root of n times square root of n. So this should be linear, unless I mess something up. But that's basically, I mean, maybe there's an additional factor there, but that's basically the idea of why this is fast enough. Just yeah. And so in the end, it is just brute force in a very silly way, if you ask me, and it's kind of tricky. But yeah, the problem was easy to understand, though, I think. So anyway, hopefully this makes sense, and this is a decent idea. Let me know what you think, and yeah, you could watch me solve it live in contest now. Give it a submit and see. Okay, a little bit cautious, but fine. Minimum number of groups to create a Reddit assignment. So each index is in one group, and for each group G, the number of indexes, what does that even mean? For every group G, all indexes are the same, okay. And then after that, okay. Group 1 is 0, group 2 is 1 and 2, okay. So basically we have to try all possible numbers. I mean, maybe in a smart way, but basically you have to try to see if you do, and is it always possible, and yeah. Is it always possible? I mean, first we want collections are counting. F for frequency table, but so basically we want to see if we could put everything in a group of, let's say 1, then it'll be 1, and we want the minimum number. So is it binary search? Because if it's too big, it's not possible. Is that always true? Well, too big is definitely not always possible, but if it's too small, is it always possible? Multiple of because then let's say we have some like weird thing where you have like given maybe level 4, 4, 4, 4, 4, 1, and in theory then 4 is not possible, but 3 might be. No, 4 is possible when you just put the 1 into the 5, right? If it's too small, it's not always no, it's always possible. Just break it into more groups, yeah. If it's too big, it's not possible. Because leftovers is always going to be, you cannot have a leftovers more than groups, right? Well, you can, if it's like 5 and 4 and then 3 and you want to do 4, then you cannot just roll it into the 7. So you would not be able to do it because it's, but that's because it's too big, right? So you try a smaller one. And if it's too small, that should be always be good because you're gonna wait. All right, let's try it. 10, 5, it should be good enough. That's, maybe even n should be good enough. Yeah. So now this is the minimum number. Oh, the other one is minimum number of groups, and the minimum number of groups is going to be maximum number of group size. So I think that makes sense. Okay. So if this is good and this is the smaller number, then we try something bigger. Otherwise this is not possible, so okay. And then otherwise return calculation of left. Okay. Right. Is there an impossible case? Shouldn't be. Okay. Okay, so let's say this is the target. Then for v in f.values, oops is equal to 0. Let's say okay, right, so let's say target, right? So current groups is equal to minus divided by target, right? And then leftovers is equal to right? So if number of leftovers is greater than groups, then it is no brainer, because basically we want to keep things target and target plus 1. So left is oh yeah. So that means okay, yeah. True, and then this is just this is actually reshadowing as well. Maybe just go cow. Terrible naming. So now this is the number of the lower number. So we just this is the same code really, except for that we distribute all the rings to G. So yeah, something like that maybe. Feel like it should be okay, but I don't know if I'm confident about it. And this one has 6 for some reason, so that's not even great. But I'd rather get it wrong now than giving a submission. So let's take a look. Left is 1. Y1. Oh, 1. So then it puts 2. Okay, so I think the idea is still going to be right. I mean, this 1 is correct in that that's the number of low group number, but we have to be able to greedily choose 2. So that means that we want to do this, right? We have to do something like so the smaller one should be okay, but something like G2 is equal to v target plus 1. So now we're trying to do target plus, right? If L2 is greater than G2, then we add it to G. Otherwise, we take the smaller group, which should be G2 to be honest, but I'm lazy to kind of fix it. 2 and 3, is that right? So divide by 2, this has 1 group. That's not true. Oh yeah, because you can't do the leftovers anymore. So basically leftovers have to be, because we can't add it anymore on the bigger side, so it has to be either 0 or G2 minus 1, which is target. Okay, and then this is the good one, and this, okay. And then now this is 1 and 4. Why? Because it thinks 2, so then now it tries to do 3. 4. Tries to do, so the answer is 2. It tries to do, so this is 0 and this is 2. Oh, this actually, okay, yeah. If L2 is greater than 0, G2 we have to increment by 1 because that's a group in itself. This is a way, I'm getting it wrong a lot, am I? So this one we want to try 2. So 2, just remainder is by 1, right? But that also means a group, so then that means 2. So 1, we try to do 2. Is this always the case? No, this is always the case, because if L2 is, then it just happens to match perfectly. Though it shouldn't happen, right? Target plus 1 will never, actually maybe it would because of this thing. But this is not, I think the G thing is wrong as well, maybe. Because basically, if this is 1, then this is, no, this is 1, this is 2, but then it tries to, okay, let's just print it out then. Oops, there's a fly on me. Yeah, Hong Kong. So the 3, it finds a group of 3. That's not good. It's basically 3 and 0. So the G is going to be 3. This is going to be, should be 2. Right? G2. Why is it not doing L2 is equal to 0? Oh man, I do not know how to code. I mean, it's still wrong, but that is just really wrong because this is, yeah, whoops. Okay. No, this is not right. This is target minus 1. Oh no, this is target. Oh, okay, there we go. Very easy to do off by ones. Am I confident in this? Not really, but let's give it a submit. Okay, fine. Let's see. I have 2 groups, we have 1 groups. Okay. What did I print? I print out 2. Oh, so we cannot do 3. 4 off, but 5 is fine. So maybe the binary search is not right. Okay. That's the kind of thing I was looking for, but I wasn't quite ready to find. Or able to find. Like the discontinuity. Okay. Is this the only case? No. Let's see, right? What would I return for this? I should return 2. How is this getting 5 but not this? What is the difference here? Is it because my binary search is terrible? Or maybe just lucky even? Yeah, okay. So it's giving me different answers depending on, because I think I just got lucky on NO with 2. And then it just kind of picked 5 as the first one or something. So that's why it chose 2. Man, I thought it would be one. Yeah, I'm struggling on a medium. Did I misunderstand any of this? Number of indexes. We say you have these values and then you try to divide them into, but in this case you could divide them into 2 and 3, but not is this the only discontinuous case? Man, I am struggling. How am I doing so far? Oh, I mean, poor on the first 2, but I don't know how many percent of Q3 actually. Can I binary search on groups? I don't think that I can, but I mean, I think that binary search isn't going to work even in other cases. Now that I think about it, because it has critical points on n and then n minus 2 and then n minus 3 and so forth. Maybe. And then if it's a CIF thing, everybody's sad. But I don't know how to do this one. People got it very quickly too. Well, it's early, so other people got it less quickly, so maybe I don't feel so bad. But I don't think I understand it still. Command one by one. No, I mean, that's just n square. I don't think there's any way to speed that up. Is there a way to speed it up? Like, can we brute force in a smart way? In like some sort of sweep line where it only changes on. No, because it goes to impossible, right? And then another one, so we can't really do that. And then just F values thing. I don't think I'm just any other way to read this. I think this is fine, but or like the reading is fine. I don't know how to do it. is the number of groups always one of the numbers? But even then it may be n squared, so I don't know that that's fast enough. Is there some visualization about the area or something? Basically, if it's too small, it's always possible, but it's too large, and it's not always possible. But then if it's large enough again, what is too large not possible? What is this one? But then we have to try every like big number, and that's just, like I said, n squared. Alright, I'm gonna come back to this one. I feel like, I don't know, just struggle more than I should on this one. Alright, let's see. Minimum changes. I'm just gonna YOLO this one, I think. The min number is this. Well, we have to try the min number, right? So, because that's the biggest thing that we can try. This bug. I don't know. I mean, I think maybe there's some like weird oh no. Oh no, I lost my case. Oh no, it's just this one, so I guess that's fine. Oh, yeah, okay. I mean, it's just whether it's fast enough, right? Or, you know, not divided by 0. What is target? Oh. What? Target is 0? Why would target be 0? 25. Why is target 0? I starts at 1. Huh? What? Why? Tell me why? Oh, whoops, this thing. YOLO submit. Oh, I should have tested the big one first. Oh well. Well, this is not right anyway, but I wanted to see the speed. I guess. Yeah, I guess that's not really a big case. What would I get wrong? 7. My answer is 7. My group is well, 1 is 8 groups, 2 is 7 groups. We could do 6. So I guess that's that means that idea is a little bit wrong. We go up to 3. for 2 it's 7. Is that true? That's 5 groups here. 6, 7, 8. No, 7. Oh, this one we can also try. Wait, but don't. G2 is. So we tried 3, right? So 3. 10 is going to be 3 groups. And then the number of leftovers. So if the leftover is 0, that's fine. If the leftover is equal to target, I think it's just if this is this formula is wrong. I'm thinking about it. Okay, so it's basically if it's equal to 0, then okay, let's just write write this a little bit differently. Right, so L2, if L2, the number of leftovers, if that is greater than G2, then G2 is equal to infinity, say. Right? Otherwise, if we have an extra, is that even true? Because we can just add it to this, right? And this is not necessarily true. If and L2 is not equal to target, then we do this. Otherwise, and then we can just do this maybe. All right. Do I print too much? Yes, I do. Huh. I have to think about, it's all about analysis. I was just YOLOing a little. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm and this explanation, all this stuff. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.